Okay, in this system, there is these three forces acting on the mass, which is the force from the spring, the weight, and also the reaction force. Okay. Alright. So now we want to consider the force acting on the mass in horizontal direction. So this equation is incomplete because of this format is not suitable with my gadget, but it's fine. I will write down the equation so we can learn with it. Okay, so actually the complete equation is like this. So we consider the right direction is the positive direction for the x, okay, and also for a positive direction for the acceleration. So we have sigma. Sigma is the summation of F, the force, is equal to the acceleration of the mass. Okay, so AX means the acceleration is has a similar direction with the x. Okay, so we have considered the diagram, and we know that this is the formula. Alright, so actually this is the formula that we want to find. There's two dot at the top of the x. Okay, so hopefully after this we can get this formula. Okay, the acceleration is proportional to the block's displacement. Again, acceleration is proportional to the block's displacement. So when the acceleration, when the displacement is high, the acceleration will also be high. Therefore, we call it a simple harmonic motion, because usually when the free vibration happen, usually it is involve simple harmonic motion. So again, the formula down here is incomplete. This is omega equal to 0. Okay, never mind. Okay, from this equation, we can get this equation. So again, actually this summation of F is equal to, the only force in horizontal direction is the spring. Okay, so spring equation is equal to this one, kx, the force in the spring, and also we can replace the a, the acceleration, with x double dot. Okay, so x, when we differentiate it, we can get x dot, which is velocity, and when we differentiate it twice, we can get acceleration. Okay, so this the x is related with the x double dot. So when we rearranging the equation, we put the this component to the other side, or otherwise. So right, so 0 is equal to m x double dot plus kx. Alright, and we can simplify it even more. So we have the similar form, this one and this one. Alright, now we want to compare these two forms. So we can see that this equation, this component is equal to this component. Therefore, we can get that the equation for omega n. So what is the omega n? So omega n is the natural frequency for the system. So that is the simple system, and it has the natural frequency. Same goes with the complex system, which involve so many springs, so many damper. They have their own natural frequency. And natural frequency unit is radian per second. Okay, so this equation is derived from the comparison between this equation with this equation. When we compare, we can get that omega n square is equal to k over m. Therefore, omega n, or the natural frequency, is equal to this equation. So that's why we get this equation. Okay, now I need to complete this equation again. Alright, so this equation is a homogeneous second order. So this is the name that you have learned in maths 2. Homogeneous second order equation, linear differential equation. Homogeneous second order linear differential equation with constant coefficient, and therefore the general solution, you can get this in the maths 2. The general solution for this equation, for this equation, is a sine omega n plus b cos omega n t. T is time. Alright, so where t come from? Because this is a periodic so vibration is a periodic movement, so we have time related to the motion. Okay, so next we can simplify the we not simplify, but we we can replace the component A and B with other constant. The constant A and B, we can replace it with another constant, with only one constant, which is C. Because the equation is expressed in terms of simple sinusoidal motion, so it can be replaced with a single component, a single constant C, with sinusoidal component, just this one. So where C and psi are new constant to be determined in place of A and B. Therefore, when we replace it inside this equation, we get this. Okay, we get this equation. Okay. Since this is the formula that we know, sin theta plus psi equal to sin theta cos psi plus cos theta sin psi. So this is the new form that we can get. Alright, so this is the simplified solution that we can get from the differential equation of the vibrating system. if this equation is plot on an x versus omega nt axis, so this is x against omega nt. The graph shown in figure below is obtained. Okay, so we want to see the behavior of the x. X is again is displacement, displacement of the spring, displacement of the mass. Alright, so we can see that the amplitude is c, right? The amplitude for the top and the bottom is c. The period one cycle 2 pi is equal to omega nt, omega n tau. So the period of time is tau. And if you look at here, the initial position is this equation, but for the psi, sin psi, c sin psi. Okay, for this one it's easy. You just place t is equal to 0, you will get this. Okay. Alright. So actually psi is the parameter for the phase. Phase is like the displacement of this. If you look at here, this is the normal curve, which is start from 0, right? But we psi right here move the curve backward. So psi define the phase of the vibration. Okay, the maximum displacement of the block from its equilibrium position is defined as amplitude. Okay, from the figure, the amplitude is c, like I said, and the angle psi is the phase angle psi, like I said just now. It is define the phase of the vibration. Alright. So C is another way to calculate. C is from A and B is this equation. And psi, how to calculate it is, this is negative. Alright. So this is the formula to calculate amplitude and phase angle. Amplitude, phase angle. Right. Note that the sine curve completes one cycle in time t. T equal to tau. So tau is the period. So how to calculate tau? Is 2 pi over omega n, the natural frequency. So where do we get this from? It's from here. From this equation. Right? So you need to know the equation for the period. Right. 2 pi over omega n. The length of time is called a period, okay, which may be also represented as, so another formula for tau, actually we just replace, we replace the omega n with this equation. Like I shown you just now, before this. So we get the new formula for period. Okay, sometimes in question you will be asked to calculate the period. So usually this is the final outcome of the question, the parameter that we want to find for any problem given. Alright. Okay, sometime we will need to calculate the frequency. So I'll complete this equation again. Alright. So this is the formula for frequency. Either 1 over tau or equal to omega n over 2 pi or equal to 1 over 2 pi time surd k over m. Okay. And the unit is hertz. Sorry. Okay. Or second negative one. Alright. The frequency is expressed as hertz. So you need to remember, maybe this is the answer that we need to find from any question related to this this type of problem. So when a body or system of connected bodies is given an initial displacement, the x, from its equilibrium position and release, okay, it will vibrate with the natural frequency. Okay, remember when there is yes, this problem happen where we apply extension for a system and then we release it. It will vibrate without any external force, so the frequency will be natural frequency. A different body has different natural frequency. Remember that. So natural frequency is related to resonance. So you will learn about resonance afterward, don't worry. Provided the body has single degree of freedom, then the vibrating motion of the body will have same characteristic as the simple harmonic motion of the block and spring just presented. Okay. If single degree of freedom, the vibrating motion has similar characteristic with simple harmonic motion of the system itself. Okay. Again, you need to remember what is the simple harmonic motion, like I said just now. So consequently, the body's motion is described by a differential equation. What is the differential equation? Double dot plus omega. So this is the equation we got before this. So this is the standard form. This is the standard form of the differential equation for the vibration. Okay, for the free vibration. Hence, if the natural frequency of the body is known, so after we get the natural frequency, we can calculate the period, we can calculate the frequency, and other characteristic of the vibrating body. Right. Now, we go to the next another way to calculate to consider the vibrating body, vibrating system, the first thing you need to do is, actually we have done this previously in the previous problem, which is the free body diagram. Okay, what is free body diagram, FBD? We need to draw the free body diagram of the body when the body is displaced by a small amount from its equilibrium position. Okay, so what is FBD? I will show you after this. Now we need to draw again. We need to draw the body after it's being displaced, a small amount. Okay, because after we displace the body from its equilibrium position, then there will be force. Okay. So in this case, we use inertial coordinate Q instead of X. Okay. Don't worry about this. This is usually related to X, so it will have similar kind of equation. So how to draw FBD, free body diagram? So this is example. We have a slope and we have a block. So we don't know what is happening to the block. So what we can know is the block has mass, and there will be a friction between the block and the slope, and there will be reaction force. So we just draw the free body diagram. So this is the free body diagram. So we have weight, we have reaction force, we have friction force. Okay. So the direction should also be correct. So the friction will against the motion. The weight is downward, and the reaction force is perpendicular to the slope surface. Alright. And also we can draw kinetic diagram. Kinetic diagram is different with free body diagram. Kinetic diagram is the motion of the block. So this is the kinetic diagram. So the motion, the force involved to move the block. So the force is the mass time the acceleration. What is the acceleration? We can calculate it. Okay, it is related to the gravity and also the friction, right? So this is the kinetic diagram. This is the free body diagram. You need to remember that, and you need to be able to differentiate it.